Hi everyone, welcome to another video. Today I'll show you how to control a stepper motor with ESP32. Okay, so let's connect everything together. This is the stepper driver I'm using. It's ULN2003 APG. It's from AliExpress. So you connect the motor to this pin header, ground and 5 volts. Then we'll use another 4 to control the stepper motor. The pins on ESP32 of my choice are 16, 17, 18 and 19. And then we need to connect ground, it's right here, and this pin vein is 5 volts, which we need to power the motor. It says here 5 volt DC. And don't make a mistake and connect it to 3.3 volts because it won't work. So when everything is connected together, let's power our microcontroller via USB and let's go on the computer and write some code. So here we define which ESP32 pins are connected to the stepper driver board. The stepper motor itself is not connected directly to the ESP32. The microcontroller only sends control signals to the ULN2003 board, and the driver board powers the motor coils. These pins, in 1, in 2, in 3 and in 4 on the driver board are connected to GPIO 16, 17, 18 and 19 on our ESP32. Here, this value defines how many half steps the motor needs for one full revolution of the output shaft. For this type of stepper motor, we commonly use 4096 half steps per revolution, which means the motor moves in very small steps, which gives us precise control over the position. Next, we have all 4 outputs in an array. It just makes the code cleaner because later I can loop through the pins instead of writing 4 separate digital writes commands every time. This chunk of code is the most important part of the code. The stepper motor moves by energizing its coils in a specific order. Each row in this table represents one step. High means that the coil is turned on and low means it's turned off. By moving through this sequence from top to bottom, the motor rotates in one direction. If we move through the same sequence backwards, the motor rotates in the opposite direction. Then we have this enum. It tells the program what the motor is currently doing. The motor can be stopped, it can spin continuously, or it can move a specific number of steps. This makes the code easier to understand because we are not just using random numbers to represent the motor state. Then we come to the speed variables. The motor speed is controlled by the number of half steps per second. The code converts that speed into time interval in microseconds, so instead of blocking the program with delay, we check when enough time has passed and then perform the next step. For this apply step function, it actually sends the step pattern to the ULN2003 board. It takes one row from the half step sequence and writes those high and low values to the 4 ESP32 pins. This is the moment where the driver board LEDs change and the motor moves one small step. SetSpeed function changes the motor speed. It also limits the speed between a minimum and maximum value, so we do not accidentally set a speed that is too slow or too fast for the motor. Then it calculates the delay between steps based on the selected speed. Start continuous function starts continuous rotation. If the direction value is positive, the motor spins clockwise. If the direction value is negative, the motor spins counterclockwise. The motor will keep spinning until another command changes the mode or stops it. Move steps function moves the motor by a specific number of steps. For example, when we want one full revolution, we tell the motor to move 4096 half steps. The code stores how many steps are remaining, and every time the motor moves one step, the number goes down. Here we have serial command handler. This part reads commands from the serial monitor. Each keyboard command calls a different function. For example, the F key starts continuous clockwise rotation, B starts counterclockwise rotation, and R makes one full clockwise revolution, as you can see right here. Then we come to step 1's function. This function is responsible for timing the motor movement. It checks if enough time has passed since the last step. If yes, it performs the next step. This is important because the program does not stop and wait. It can still read new serial commands while the motor is running. In setup, we start the serial monitor, configure the 4 ESP32 pins and as outputs, release the motor coils and print the help menu. As for loop function, it's very short. First it checks if the user typed a new command in serial monitor, then it services the stepper motor and moves it if it is time for the next step. Because of this structure, the motor can react commands in real time while it is already running.
Okay, so as you can see, everything is connected. I flash the code on the ESP32. Then if I press R, it starts to rotate the motor for 1 revolution. We can type question mark to see every single command. We can type F for continuous rotation and plus to speed up the motor. As you can see, it spins really fast now, and minus to slow down. And now you can see LEDs started to blink because they're changing the coils much slower than the max speed. As you can see right here, we can press B for counterclockwise, play with speeds, and what else do we have? Slow preset, medium, high preset. So yeah, you can play around, you can change your commands to do things you like, and that's it. Okay, thank you guys for watching this video. I hope it helped some of you. You can leave the comments on what should I change or improve, and I'll see you in another video. Thanks, bye.